Good morning, Emilia.
Good morning.
Hi, how are you?
Good.
Let me I try to put my camera, but I don't know what happened with that.
Yeah, it's okay.
So give me 1 minute. Okay. 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 You know. Okay. Do you hear me?
Yes, I can hear you.
Okay. The student we're doing now.
So we should wait them to enter too? Like,
Yeah, you can start now, but let me see how many students is here.
as well, you need to let me to share screen.
Yeah. Okay, Emilia. Okay, guys, welcome. Good morning, guys.
Good morning.
Good morning, teacher.
Good morning. The class going to be the start right now, so just enjoy the class and remember, if you have some question, you turn your microphone and ask your question to the teacher. She wants to respond you, or you can chat. Okay, send your question, or you consult to the teacher. Okay, by chat. Okay, you have to participate in the class. Okay, guys, ready? Emilia, that is you.
Okay, so I will prefer if you chat, like if you don't chat, then if you ask like using voice, because usually more people have the same questions about stuff, and everyone will get it.
Yeah, exactly. Okay,
more clearly.
Okay, guys, you have to use the chat, okay, and the teacher going to respond your question, okay?
Yeah, it's easier if you ask out loud. Okay.
Okay, excellent, guys. Okay, ready, guys?
Okay, today we're going to talk about coordinate geometry. So every place of the planet has his coordinates that we can easily find it on the map. Just we can imagine like our Earth is like coordinate system that have lines that are latitudes and longitudes. The 0 degree, it's Greenwich longitude, and the 0 degree equator latitude are starting lines of the coordinate system. So you can imagine like coordinate system with two different lines. So it's like this one is the x-axis and the other one is like y-axis. So, but this one, like the one that is like world map, is like it is in more dimensional coordinate system. Now we're just going to talk about plane coordinate system that's on the plane just with two axes. Otherwise, they exist 3D dimensional coordinate system with 3 axes, 4, and so on. There are like a lot of them. So coordinate geometry is a study of geometric figures by plotting them on the coordinate axis. So we can plot on the coordinate table straight lines, curves, circles, ellipse, hyperbola, polygons, and everything else that you can imagine right in the coordinate system. So this is a Cartesian coordinate system. It's two-dimensional. You can refer it as a coordinate plane as well. We have x and y axis. And on this x and y axis, we have 4 quadrants. Quadrants are the ones that are here, space that they x and y axis, they catch the space. So for example, in the first quadrant, the x and the y axis are both positive. In the second quadrant, x-axis is negative, as we can see, and the y-axis is positive. In the third quadrant, the both x and y-axis are negative, and in the fourth quadrant, we have the x-axis positive and the y-axis negative. I think this one, like before with the coordinate system, is more like, I think everyone is knowing, so I consider that is already know, it's just like revision. So now we're going to talk about distance, the distance formula between 2 points. So the distance formula is the length of the line segment that is joining the points. So there is only one line points, and we want to find how much is the length of that line. So for example, if we have 2 points with 2 coordinates, A, x1 and y1, and B with x2 and y2, then D equals to square root of x2 minus x1 squared plus y2 minus y1 squared is the distance formula for these 2 points. As well, if we have a point P, x, y, and the other point is it's in the origin. The origin is the one, let me go back a little bit. So this is O, where the 2 axes intersect. So this is the region that has 0, 0. Then the distance point for the point P will be x squared plus y squared. As well, we will talk about midpoint. So midpoint refers to the point that is in the middle of the line between 2 points. So the 2 reference points are the endpoints of the line, and that point lies in between them in the middle. And the formula to find the midpoint of two points, so x, y, 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 and x2, y2, is the new point m, x, y, and this is like this we can find like x1 plus x2 divided by 2, and the y coordinate we can find by y1 plus y2 divided by 2. So now let's solve some exercises so we can see like how we can find this one in the real life. So let's see. So the distance, we should find the distance from the point 0, 5 and minus 5, 0. So I'll just write down first the formula. So the formula for distance of 2 points was square root of x2 minus x1, sorry, 1 squared plus y2 minus y1 squared. So now I can put this one like x1. The other one will be y1. This one will be x2. And this will be y2. So now I can directly like put the numbers inside the formula. So we will have for the formula d will equal to square root. Instead of x2, I will put minus 5. Now we have minus. Instead of x1, I will put 0. That will be squared. Plus for the second one, we have y2 is 0. Minus y1 is 5. And that will be also squared. So minus 5 minus 0 is just minus 5. When I square it, it's minus times minus, so the result will be plus. And minus 5 squared will be 25. Is this clear to everyone? Because it's minus, the number is minus that is squared. Again, we have the same thing for the second one. We have minus 5 squared, and that will be 25. So the distance d will be equal to square root of 50. I can write 50 in order to take out something in front of the square root, like 2 times 25. And we know that square root, so I can separate this like 2 square roots. It will be like square root of 2 times square root of 25. And we know that the square root of 25 equals to 5. So we can write down that the distance is 5 square root of 2. Because for square root of 2, we don't have clear number, like real number. Is it clear, this one?
Guys, it's clear?
I guess so. If it's clear, I can go on the second one. The second one is the distance from P from the origin. This is the second example that we took. So the distance was equal to square root of x squared plus y squared. This one is just because the origin has coordinate 0, 0. So when I plug it here in the formula, will be minus 0 in the both. So it will just stay minus 6 squared plus 8 squared. So if this one is x, this one is y, we'll have the distance d equals to square root of minus 6 squared plus 8 squared. Then the distance d will equal square root minus 6 squared is 36. And plus 8 squared, that is 64. So d will equal to square root of 100. And as we know, the square root of 100 is, so 10 squared give us 100, 10 times 10. So that means that the square root of 100 will be just 10. So the distance between the point and from the origin, from the point P, will be 10 units. Now we're going to use the formula. I think this one was clear as well because it was even easier than the first one. And for the third one, we need to find the midpoint. I'll write down the formula first. So the formula for midpoint M will equal to x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So this will be x, this x1, this will be y1, this will be x2, and the other one will be y2. So I can plug in inside the formula, and we will get that instead of x1, I will put -2. Instead of x2, I'll put -6. So here we'll have plus from this plus, and then -6 divided by 2. And for the second coordinate, we'll have 8. Again, we have plus. And the second one is -4. So y2. So from the first one, we have -2 from the first one. Then we have plus times minus. That give us -6 divided by 2. And the second one, we have again plus times minus. And we'll have -4 divided by 2. So we have coordinates. The first coordinate will be -2 -6. That is -8 divided by 2. And the second one will be 4 divided by 2. Or M will have coordinates. The first one will be 8 divided by 2 minus 8 divided by 2 is -4. And the second one will be 4 divided by 2, and that's 2. So the midpoint will have coordinates -4 and 2. Is it clear, this one, to everyone as well?
Guys, is clear?
Is it clear? So I can continue to the others.
Do you understand everything? Yes, guys?
Okay. I'll assume that it is good. Okay. So. So now we will talk about slope formula. So the slope is the line in the inclination of the line. So can be calculated from the angle made by the line with the positive x-axis or by taking 2 points from the line. So if we have slope of line joining 2 points, so x1, y1, this one, and the other one x2, y2, the slope, so this is the slope, will be equal to y2 minus y1 over x2 minus x1. So this one will be y2 minus y1. So this part, and this is the other part, and then this is the formula M. That's the slope formula. So now we have the equation of the straight line. So this was just the slope. Now we need to write down the equation. So the general equation of straight line is y equals to mx plus c, where m, it was the slope. So this one that we calculated before. So, and the c is the y-intercept. So the c is the y-intercept. That means the point where this line crosses the y-axis. So where they cross. Okay. So the most common form of the equation, the straight line, is used in geometry. So this one is the most common that is used, but there are otherwise that we can use. So the standard form is this one, ax plus by equals to c. We have the slope-intercept form. This one is the most used because we can clearly distinguish each of the variables. So for example, we can distinguish the y-intercept and we can plot it easily. And then we have point slope form, that is y minus y1 equals to mx minus x1. This one is the most used if we have given point because it's easier, like we can plug it. Now we will have exercise with that one. So you will see how we can use this formula in order to write the equation of the straight line. So here is one of them. So we need to find the equation of straight line that passes through the point 1, 3 and minus 2, 4. So we are going to use this equation here, point slope form, in order to find that formula. So in order to find the equation, so we will have y minus y1 equals to m x minus x1. So this is the formula. Now from the previous slide, we saw that m equals to y2 minus y1 over x2 minus x1. I can plug this inside the formula, so I can solve all of it together, or we can like them separately and then just plug in m inside here. So I can now I will do them separately and I will plug m afterwards. So for first we need to find how much is the slope, so m. So here I will write down, this one will be x1, this will be y1. These are the 2 points given. This will be x2 and this will be y2. So here in m, we will equal to y2 equals to 4 minus y1 equals to 3 over x2 equals to minus 2. Then we have minus x1 equals to 1. So we will have that the slope m equals to 4 minus 3 is 1, and minus 2 minus 1 is minus 3. Okay? So now I can use this one as well, x1 and y1, to plug it here, and m that I found in order to find the form, so the line, y minus y1 is 3 equals to m is 1 over minus 3. Then we will have x minus x1, that is 1. So this is the form, but the form is kind of really long because it's not ordered. So we want to make it look better. So first, it's easier if we leave this minus 3 that is down, so not to have fraction. So in order not to have fraction, I will multiply everything by minus 3. So I can use like lose this minus 3 here down. So first, if I multiply the first one, y times minus 3, that will give me minus 3y. That I have minus times minus. So we have minus 3 times minus 3, that will give me plus 3 times 3 is 9. Do you understand this, or should I go a little bit slower, like write down the previous steps? Or is it clear? So I just I just multiply everything by -3, but I don't know if it's clear for you because I just skip one step. I just multiply directly. That's why I'm asking. Okay. So it's clear. Okay, say on the other side, we'll have -3 times 1. That will give me -3. Down we have -3, so I can eliminate -3. And this one will stay in the brackets x minus 1. So we will get -3y plus 9 equals to x minus 1. So first now we want to transfer. I will write down the other way so it will be easier for you to understand. Like I'll just swipe the places. So I will write down x minus 1 equals to -3y plus 9. So first we will do like x and y to be on left side and the numbers to be on right side. So instead, in order to have 3y on the left side, I should add plus 3y on the both sides in order here to lose 3y. So I should add plus 3y on the both sides. I'll just continue here because I will not have space. So here. So we will have x plus 3y minus 1 on the left side, and on the right side, we lose minus 3y with plus 3y, and it stays just 9. So now just eliminate -1 from this side, we will transfer to the other one. So I will add 1 on the both sides in order here to be 0. And I will get the normal form, that is x plus 3y. We eliminate -1 will equal to 10. Was this clear to everyone? So this is like the normal form that we can get. That is much shorter than the one here that we got. Okay. So this is how we find like the equation of the straight line. And now we have like one easy one, but we want to write the equation. So the cost, this is like real life problem that you might find it. So the cost of a notebook is $5 more than twice the cost of the pen. So represent the situation as an equation of the straight line. So first, does someone have any idea how we can start this? So first we need to represent in the straight line. So what we are missing, like what we need in order to write equation. Does someone have idea or no? Okay, so I can proceed then. So we can write down like the pen to be x. And then the notebook we can write to be y. So the cost of the notebook will be y, and the cost of the pen will be x. So how to write the equation? So the cost of the notebook, it says is $5 more. So 5 plus, because $5 more, that means 5 plus. Then twice the cost of the pen. So twice, that means 2 times the cost of the pen, and the cost of the pen is x. So this is just the equation that we need. So y equals to 5 plus 2x. We can change the places to get the most used form. So 2x plus 5, because we don't have minuses, so they're easy to change. So this will be the equation of the straight line representing the notebook and the cost of the notebook and the cost of the pen. Is it clear to everyone? I think it's easy. Just we need to the cost, we need to change it with y and x. Okay, so I can continue with the next slide. So now we have triangles and coordinates. So a triangle, three-sided polygon that has 3 edges, 3 verticals. We know that the area of the triangle is in two-dimensional plane, and this is the formula, is 1/2 of the base times the altitude. And now this was like how it's given, like, I guess everyone knows this. So then we need to find the distance between the point A and B. So the distance between the point A and B, we can find in 2 ways. First, the triangle is right triangle. So when they're given in the coordinate system, we can count the units. So for example, here, we have 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 units up. And 6 units from this point, it's not given here. We have 6 units from this one till B. So now in order to find, we can use the Pythagorean theorem. I was explaining the previous class. So we have like the sides times the height. So this is the side times the height squared. The side squared times the height squared give us the hypotenuse squared. So the hypotenuse actually is the length of the AB side. So, or I can use the other form like C equals to square root, because here is squared. So the opposite of square is square root, equals to A squared times plus B squared. So A is the side, so A is 6 units here. And B will be 8 units. So this will be B. So I will just change inside the formula. So we have that C will equal to 6 squared plus 8 squared. And we will have that C will equal to square root 6 squared is 36. Plus 8 squared is 8 times 8 is 64. So we will have that C will equal to square root of 100. That means that the length of the distance of the points A and B is 10 units. Okay? So I think this is clear. We're just using like the formula for that is given here. So the Pythagorean theorem of the right triangle. Triangle is right, we see here the angle is 90 degrees. So we can use that formula for right triangle. Okay, so now we will have like, we have a same the distance of the 2 points. So this is the first one, 2 and 5. And the B point has coordinates 8 and -3. So now, but they're not like represented on the graph, as you can see. So in order to find, like here was given a triangle. So it was easier because they were represented on the graph and you could have find these units in order to find it. But here we are just having the points A and B. So we want to find the line that is connecting these points. So this, the distance of this line. So we can use the formula that we mentioned before, that is for the distance between 2 points. So that was D was equal to square root of x2 minus x1 squared. Sorry, x1 here. So x1 squared plus y2 minus y1 squared. So we can use this formula and we will get that the distance D will equal to, instead of, so this one will be x1, this will be y1, this will be x2, and this will be y2. So instead of x2, I can write down 8 minus x1 is 2. That will be squared plus for y2, I can write down minus 3 minus for y1, I will write down minus 5. That will be squared. So now we'll have the distance. We will get the same numbers from above, from that we used the previous formula. So that will be 8 minus 2 is 6. That squared will give me 36. And plus the second one will be minus 3 minus 5. They're with the same sign. So we just copy the sign and add the numbers. So will be minus 8 squared, and that is 64. So the distance D will equal to square root of 100. So again, we are getting the same result, that the distance between the 2 points will be 10 units. Okay, I think is it clear to everyone? So we'll get the distance between the 2 points the same way. So they're the same coordinates. So we need to get the same distance. Okay. So I will continue because no one says anything. So now we need to find the area of this triangle. It's right triangle. So as we know, for finding the area of the right triangle, this one, the B side actually is as well the height, the same with the height of the right triangle, because it's on the, it falls down in straight angle, so right angle. So here we'll have the area of the right triangle. As we know the formula, it will be 6, the side A times the height, that is 8 units, divided by 2. And we will have that the area equals to 6 times 8 is 48 divided by 2, or that will equal to 24. 48 divided by 2, that is 24. Okay, we just use the formula that the area is half of the side times the height. Okay, so now we have congruent triangles. Congruency of triangles. So 2 triangles are said to be congruent if all 3 corresponding sides are equal and all 3 corresponding angles are equal in measure. So this can be slided, rotated, flipped, and turned to look identical. So they can be turned, it doesn't matter how they're turned. If the corresponding sides are equal, that and the angles, then we said that the triangles are congruent. And this is the symbol of congruency that we use. So for example, here we have 2 triangles, ABC and PQR. So we'll say that the verticals A and P, so A is the same as P, B is the same as Q. This one is just rotated on the left, and then C is equal with R. So we will see that the side AB is equal to the side PQ. So let me write down. So we have this side is equal with this side. Then we will have that this side here, QR, is equal with BC. And this side, PR, is equal to AC. As well, we know that the corresponding angles, so the angle A is equal with the angle P. The angle B is equal with angle Q. And the angle C is equal with the angle R. So we see when they're all equal, it means that the triangles are congruent. Okay. So this is like what we are using. So corresponding parts of congruent triangles. So actually measuring the side and angles of the triangle, we have used that, we have different rules that we are using. So this is the most used. So side, that all the sides of the triangle are equal, that we have side, angle, side, and then also we have angle, side, angle. So let's see first side. This is one of the rules that we are using. So we will have that the two angles are equivalent to each other if the corresponding three sides are equal, or like it's described here, AC is equal to PR, PQ is equal to AB, and CB equals to RQ. Usually these formulas usually are given to triangles, and you should use one of these ones to prove why the triangles are equal. So this is what is given. Then we have side, angle, side. So this is how we can prove that these two triangles are equal. If we have that the AC side is equal to RP side, and then we have the angle. This is important, that the angle should be between the sides that we are proving. So we will have the angle A is equal with the angle P, and then we will have that the AB side equals to PQ side. So for example, we need to prove that this triangle is equal to the other one. And for this one are given like this side and this angle. I cannot use this angle. I should use this angle and the corresponding one to this one. So corresponding one to C, and that will be our angle. Okay. And then we have angle, side, angle. So this is the other theorem that is used. So we will have that we need to do the corresponding side and the corresponding angles. So for example, we need to know that the angle C is equal with the angle R. Then we have the side where the two angles lie on. So that is CB is equal to RQ. And then we have the angle that is on the end of that side, that's the angle B, equals to the end of Q. If this one is true, that means that this side as well is equal to the other one, and AC side will be equal to RP. So if we prove this, we will prove that the triangles are equal. So that was for equal triangles, and now we'll have for similar triangles. So what is similar triangles? There are triangles that have corresponding sides are in proportion to each other. So they are not equal because one of them can be smaller, that can have different size. So one of them can be bigger. And we have various methods that we can find they're similar or not. And they're similar if the angles are equal. So we'll have these angles are equal. And the ratio of their sides is corresponding. So we have the same ratio between their sides. We'll see on the next slide. So here. So they have the same shape, but not the same size. Corresponding angles are equal. So here we have the angles corresponding are equal. And the ratio between the same sides, like the corresponding sides. So for example, A side is equal as P side. So this is like flipped triangle and smaller. So A over P will equal to the ratio B over Q, and that will equal to the ratio C over R. So if this one is corrected, if this number is the same for the three of them, that means that they're similar. So now we will have one exercise. So we have the dimension of the triangle ABC and DF are given. So AB, these are the length of the sides our AB is 4 units, BC 5, AC 6, and we should use the formula to check if the triangles are similar. So the ratio formula. So we will have which side is corresponding to the other one. So we'll have that AB corresponds to DE. So we'll have that, should find that AB over DE equals to, sorry. So equals to BC over EF. And that equals to AC over DF. So if this is true for all of them, that means that the triangles are similar. So AB over DE, instead of AB, I will put 4. Instead of DE, I will put 16. That will equal to 4 and 16. I can divide them by the same number. That will be 4. So 4 divided by 4 will be 1. And then 16 divided by 4 will be 4. I can do the same one for BC. So this one was AB over DE. So we'll have that BC over EF will equal to, instead of BC, I will put 5 over 20. We can divide the both by the same number. We can divide the both by 5. So we will get up 1. And down we will have 20 divided by 5 is 4. And then for AC over DF, we'll have 6 over 24. We can divide the both by 6, and we'll get 1 over 4. So we see that the ratio for the 3 of them is 1 over 4. So that means that the ratio is the same, or the triangles are similar. Okay. So we can go to the next one. So this is like exercises for you to practice. Let's go, like, we have one more slide. I will just want to explain this one, and we'll return to the problems that I will leave you for you to solve, because we will finish. So we want to see what is the difference between the similar and congruent triangles. So for similar triangles, they have the same shape, but they can have different size. And for congruent triangles, they're the same in shape and size. So congruent triangles have the same size too. And they're in similar triangles, they're representing using the symbol for similarity. And they're using this symbol for congruent triangles. So we'll set these triangles are congruent and here are similar. And then we will have that the ratio of all corresponding sides is equal in similar triangles. So the ratio between the sides is equal, as we saw from the previous, and we saw in the previous exercise. And the ratio corresponding size is equal to 1 for congruent triangles. That means that the sides are equal. So the ratio is always going to be 1 because the sides will always be equal. Okay. And okay, that's the last one. And this is what you need to solve. So they're given using the ratio. I will just explain one problem. So it's given like the ratio for similar triangles. We should find the missing sides. So for example, in the first one, we should find out how much is the side AC. Does someone want to solve it? Or you want me to explain it? Okay, I will explain one, and the other ones I will leave for you. So for this one, we'll have that AB side. We have the side that is similar to it is DE. So we want to know that the ratio between AB should equal with the ratio of DE over DE should be equal the side AC that we are looking for over DF, because AC is similar to DF. So now I can just put the numbers for the sides that I know. So instead of AB, I will put 5. Instead of DE, I will put 25. AC, sorry, is the one that we are looking for. So I will just write AC. And instead of DF, I will put 20. So now I can just multiply them crosswise. So 20 times 5, or let's do first the other one. Sorry. So we'll get 25 times AC should be equal to 20 times 5. Or we'll get that 25 AC times AC will equal to 100. We can divide on the both sides by 25 in order to find how much is the side AC. So we'll get that the side AC will equal to 4 centimeters. Okay, so this one will be 4. Okay, I think this one is clear to everyone because the time is up and we're finished the class. I will leave like for all of you, if you're from, I will leave even the exercise written. So if you are using like computer or mobile phone or whatever, you can like screenshot the page and try to solve yourself the exercises given. They're really easy. Like this is the way that should be solved. You just need to see which side is corresponding with the other one, which sides are similar in the both triangles. Okay. So this was the lesson. Like I finished the lesson. Like, I don't know if someone has questions.
Guys, is clear or do you have any questions?
Is it clear or I should repeat something? Okay, no response.
Turn the microphone, guys.
Okay, so someone right, okay, that is clear. Okay.
Okay, guys, say it's clear everything.
Okay, so I guess it's clear for everyone. So have a nice day.
Okay, thank you so much.
Thank you for the class.
Emilia, guys, wonderful day for you. And remember, be pending for the next class. It's in Spanish at 3 p.m. So I see you tomorrow again in the next class. Okay, have a wonderful day to all of you guys and enjoy the day. Bye-bye.
Thanks, teacher.